Today's lesson is about interpreting scale drawings, finding new side lengths, and similarity. And to begin our warm-up, we have to solve the equation and find commission, which remember is markup like we did in the past. So, to begin, remember we do parentheses first and then exponents. I'm going to do it all at once. 12 squared, 144, plus 4 times 23 is 92, minus negative 22, that becomes plus. 144 plus 92 is 236, plus 22, and we end up with 258 for our final answer. The next problem is commission, which is our markup problem. So, how much is his 14% commission on $150,000 in sales? All we need to find is the markup. So we take our percentage as a decimal times 150,000. So 0.14 times 150,000 equals $21,000. And that's the 14% that he earned on the amount that he sold. To begin our lesson today, I want to present you with the question, what does it mean for two things to be similar? Because in our lesson, we're going to learn about similarity in shapes. So let's first think about what does similar mean. I know that my sister and I are very similar because we're very alike. Have stuff in common. Those are aspects of things that are similar. Now let's see how we can relate this to shapes that are similar. But first, we need to review triangles. On the screen right now are 3 types of triangles. And these similar triangles are classified by their sides. So, we have scalene triangles, equilateral triangles, and isosceles triangles. First, let's think about what does a scalene triangle have? What are some features? Its features is that each side is a different length. No 3 sides are equal. Equilateral triangles have 3 equal sides and 3 equal angles. Isosceles triangles have 2 equal sides, and then they also have 2 equal angles. Isosceles triangles sit on the base, and then the sides that are not the base are the equal sides, and the angles touching the base are the equal angles. Now, when we look at triangles that are similar, what that means is that this side right here on our scalene triangle is in relation to this side on our scalene triangle, because notice they're in the same location, if you want to say, because these angles on the inside are equal. So we have these equivalent angles right here, and then this side, they're equivalent in a way that they're proportional. So they're not the same, but they are proportional. And then every other side of the triangle needs to also be proportional in order for it to be a similar pair of triangles. That goes with our equilateral triangles. If these 3 sides on our larger triangle are the same, the 3 sides on the smaller triangle have to be all the same size, but they also have to be proportional to the sides on the big one. And note that with similar triangles, the angles never change. Just the length of our sides change. The same idea goes for the other classification of triangles. Notice that these three triangles are classified by angle measure. So we have the obtuse triangle, right triangles, and acute triangles. Obtuse triangles always have exactly one angle larger than 90 degrees. Right triangles have one angle that is a 90-degree angle, and 90 degrees are denoted with that little box. And acute triangles have three angles smaller than 90 degrees. They don't all have to be equal, but in this case they are, but they just have to be smaller than 90 degrees. When we're looking at triangles according to their angle, so to the right triangle and acute triangles, these sets of similar triangles, they have proportional sides once again, and this side's proportional with this side. At equal rates, they're all proportional sides, and all the angle measures stayed the same. So, in similar triangles, angle measures don't change, but side length does, and it has to change proportionally with an equivalent proportion or increase or scale for all the sides of our triangles or shapes. Now that we have reviewed our triangles, what do you think about our next question? Are similar shapes proportional? So if we have this triangle, and then we have this bigger triangle, this side is a length of 1, this side is a length of 2. Here we have a side length of 2 and a side length of 4, and a side length of 3 with a side length of 6. Are these proportional shapes? They're similar shapes because notice, the corresponding sides have similar angles, have similar side lengths with the same angle measurements. Angle measurements never change, just side length did. And notice that also, to get to corresponding side length, we had to multiply by 2. And so we scaled this by an equal factor of 2. And similar shapes are always proportional. Something to think about.